So the A-level requirements for this particular module seem to focus very much on amino acids. Talk a little bit about peptides, and there's a question about that at the end. A little bit about the structures of proteins, but that's just facts. It would be dead boring to put something like that in the worksheet. But the big emphasis is on the amino acids, on the structures of amino acids, and in particular their pH behavior and how the structure of the amino acid changes as you go from acidic pHs up to basic pHs. Now, one often sees amino acids drawn in the form like this, which you never actually see when you're thinking about the chemistry of amino acids, but it does emphasize the fact that we have an acid group here that has a Ka, or it's pKa, okay, and a basic group here, this amine, which of course has a conjugate acid, which has a pKa there. So every amino acid has at least two pKa's, one that corresponds to the acid form, the other that corresponds to the conjugate acid of the amine. Now, what's interesting is, of course, as I tried to emphasize in the movies, how this structure changes as the pH changes. So we draw our pH line, low pH here, up to the neutralish area, up to the very basic area. And every amino acid has at least three interesting points along this pH line. The first one, the lowest, is usually going to be the pKa of the acid group. So in this case, that's 2.34. The third one is going to be the pKa of the acid of the amine. So in this case, that's 9.69. And then, of course, there's this bit in the middle that we'll talk about in just a minute. Now, you always want to worry, first of all, about what form is the amino acid going to be in at very low pH. And I put in the worksheet pH 1.5. I could have done 1, could have done 2, could have said low pH, anything lower than 2.34. Now, as long as the pH is more acidic than the first pKa, that means that the dominant structure of the amino acid is going to be where everything is acidic. So that means that the acid group has got its proton on it, and the amine group is in its protonated conjugate acid form. Everything has the extra proton on it. So the acid has its proton that we know about anyway. The amine has the protonated form. Now, as long as the pH is less than that pKa, that first pKa, this is the dominant structure. At the pKa, and this is something that goes back to the acid-base module, half of this acid is going to be as the acid, and half of it is going to be in the conjugate base form. So less than 2.34, it's in this form. Over 2.34, it's in this form, the conjugate base of the acid. At 2.34, at the pKa, there are equal amounts of this. Now let's think about this structure here now, okay? It's got the conjugate base form of the acid group, and it's got the conjugate acid form of the base group. This is the all-important Zwitterionic structure of the amino acids, and this is the big structure that amino acids have in terms of their important chemistry. It's ionic, so therefore it's very soluble. It's got a high melting point. This is the form that it's going to have at most amino acids have in close to physiological pHs. So this Zwitterion form is the super duper form. More specifically and more detailed is where you have the acid group has turned into its base and the basic group has turned into its acid. Okay, so we have the Zwitterion form here becoming the dominant species once we're past that first pKa1. And we come up to this point here that is smack in the middle. That is the average of the pKa1 and the pKa2. So in this case, 6.02. And at that pH here, this is pretty much the only form that is present in the amino acid solution, or whatever form you have the amino acid in. Okay, and this of course is called the isoelectric point, 6.02. Now then I asked you about, well, what about at a really high pH? Okay, in this case a high pH means more basic than the other pKa2. So 13.0, very, very, very basic. At this stage, everything's in its basic form. Okay, now the basic form of the acid group is, of course, its conjugate base, and the basic form of the amine group is the amine. That's the base, that's its conjugate acid. So here's the basic form, and so the structure in the very high pH, everything is basic. And again, if I want to continue on, high pH is going to be this form predominantly, where everything's basic. And then as I go down here, come to the pKa of the amine group, well, now it's going to be 50% where it's in its basic form and 50% when it's in its acidic form. Okay, so very low pH, mostly the all acid form. The first pKa, half the acid, half the Zwitter ion. Halfway between the two pKa's, we find the Pi, where it's just about all in the Zwitter ion form. Move on a little bit, the second pKa2, it's 50% Zwitter ion and 50% the all basic form, and then higher pHs, the all basic form becomes the dominant structure. Okay, now I'm going to apply this discussion for the next three parts. I won't dwell on it nearly as much because it's exactly the same question. Now, the very last question that I pose is, well, which type of amino acid is this? And of course, we have non-polar or polar amino acids based on what the side chain is. This side chain methyl group is very definitely a non-polar side chain. So that's alanine, longer discussion than you probably wanted. Moving to phenylalanine. Again, we see the pKa1 for this acid group, pKa2 for the amine group, for the conjugate acid of the amine group. And now our side chain is just a different one. The pK values are different. Again, though, exactly the same treatment. Think about the pH line. The first pH of interest is the pKa1 of the acid group. The third one is the pKa of the conjugate acid of the amine group. And then, of course, in the middle, that we'll get to in a minute, is the isoelectric point, the Pi, that is just the average of these two. So at low pHs, everything is in the acidic form. So that means the acid is an acid, and the amine group has its conjugate acid form, its protonated form. And so there's the structure. At the pKa1, it's 50% this form as the acid and 50% its conjugate base. So see the COOH becomes the COO minus. Okay, again we see here this is the Zwitter ion. It's a neutral species overall, but it's got a anion and a cation as part of it. The Zwitter ion is really important when we get to the isoelectric point. That isoelectric point is the average of the two pKa's. So in this particular case, 5.48, and so we get this beautiful little structure here, the Zwitter ion at the isoelectric point. Continuing on, of course, now goes from where it's all the Zwitter ion and becoming less of the Zwitter ion and more of the more basic form. So we're leaving this end. This end's done, but the interesting part becomes the amine end, because at the very high pH, when everything is all basic, the amine is in its NH2 form. And this pKa2, the 9.13, is when it's 50% its acid form, which we see in the Zwitter ion, and 50% its basic form here. Okay, and then of course this again, what type of amino acid is it? This is very much a non-polar side chain there. So serine now, serine is the simplest of the ones that has an OH there. And of course, as we'll talk about at the end of this particular slide, that means that this is a polar subgroup. But anyway, same old stuff. We got an acid group, 2.21 pKa. We got an amine group for which the conjugate acid, the NH3 plus end, has got this pKa. Pop them in to the usual pH plan. At low pHs, everything is an acid. So the acid end is the acid. The amine end is its conjugate acid. 2.21 is 50% in this form and 50% in its conjugate base form. Again, here now we have a neutral species that's got an anion bit and a cation bit. So that's our Zwitter ion. The Pi, The isoelectric point, which is here, its value is halfway between the important pKs, and so 2.21 and 9.15 average to give you 5.68. So at 5.68, most of the amino acid is going to be in this structural form here. Going all the way up the other end of the high pH version, then we've got everything as a base. So we already know the carboxylic acid end has become its conjugate base well down here. Well, the amine end goes from its conjugate base into conjugate acid, into its basic form there. 9.15, it's 50% the base, 50% the conjugate acid. Okay, anything less than 9.15, this end prevails. Anything greater than 9.15, this end prevails. And of course, it's always COO minus until you get way down into somewhere here in the pH range. Already noted, this is a polar group, and so this is a polar neutral amino acid. And now finally, in this particular part of the question, we look at methionine. Okay, again, we got an acid group, the standard acid group, 2.28, the standard amine group, 9.21. Pop those in. Fully acidic version is, of course, where it's COOH, and the conjugate acid, the protonated version of NH2, so that's the structure. 2.28 is 50% this and 50% the Zwitterion. At the PI, it's just about all the Zwitterion, and that pH is the average of 2.28 and 9.21, which is 5.75. At the fully basic end, well, everything is in the basic sense. So the basic end of the carboxylic acid is the COO minus. The basic part of the amine is NH2. So there's that structure there. So at 9.21, 50% the NH2, 50% the NH3 plus. And then this side chain here, even though it's got that sulfur in there, it's not SH, which is cysteine, which should have been a polar. You've got that extra methyl group on there, which makes it non-polar. And let's just move the Zwitterion over like that.